Hello friends, today we are going to describe the finding of the nth term of the Fibonacci series in the way of recursive function, that is by using the concept of recursion. We have done the same program in the previous videos as by implementing the concept of the loops, and we have done it with the for loop construct, but in this program we are going to deal with the determination of the nth term of the Fibonacci series by means of this recursion, the concept of recursion or the recursive function. So, as you know, the Fibonacci series goes on like this: 0, 1, 1, 2, 3, etc. So, in that previous video, I have taken this to be the first term, this to be the second term, third term, fourth term, and so on. But in this program, in order to cater for the base value or the base criteria, we are going to take this as, for our convenience, to cater for the boundary value or boundary criteria, we are going to take this to be as the 0th term, this is the first term, this is the second term, this is the third term, and so on. So, this term should be taken to be the 0th term, this one should be taken to be the first term, this one should be taken to be the second term, this 2 will be taken to be the third term, and so on and so forth. So, by implementing this logic, we are going to write the program. So, let us get started with writing the program first and then explain you by putting some sample values in the program. So, as we have written the program now, let me explain the code line by line. Hash include stdio is the final inclusion directive. This is the function prototype in which we see that the return type is int. The name of the function taken by me is recfibo, and this int is the data type of the argument. One argument is to be supplied, which will be an integer argument. Now, the int main section, we will declare two variables, int n and f. This int n, f, n means the number, the term which the user wants to get printed as the nth term of the Fibonacci series. So, n will be the term which the user wants to get printed as the nth term of the Fibonacci series, and f will store or the value of the value which is returned by the function is to be assigned to the variable f. So, f will definitely give the output or the result of the program. So, this then comes the printf statement, enter which term, the user gives the number of terms, which term to be printed by means of this ampersand n from the standard input device. Then function call is written in this expression statement as f is equal to recfibo n. So, n this n is the actual argument, as you all know. And whatever the value which is returned from the function is going to be assigned to this variable f. And now there is an if else checking. If f less than 0, we are going to print this output as invalid input. Otherwise, we are going to print whatever is in the value in the variable f. After that, return 0 and closing brace of the main section. Now, the function definition has been written in this manner. See this int recfibo int x. This int x is nothing but the formal argument, that is the copy of the value of n which has been passed by this function call statement by means of this actual argument. So, that value of n will be copied to this formal argument x, and now we have written an if else if ladder construct to deal with the entire logic of determining the nth term of the Fibonacci series. So, in this program, in this function rather, we have written if x less than 0, that is if any input which is coming from the user to be a negative input. So, the negative term of any series cannot be determined So, in that case, we are going to return a negative value from this function, that is return -1. F will be assigned to a value of -1, which will be checked by this expression statement, by this if statement rather. If f less than 0, we are going to print invalid input. So, that is the case of the invalid input. So, now we are left with the remaining situations, that is user gives the 0th term, user gives the first term, and so on, user gives the second term, third term, and so on. So, these are all valid inputs. To deal with the As you all know that, let me just recollect once again the Fibonacci series 0, 1, 1, 2, 3 like this. So, 0th term is 0, first term is 1, second term is also 1, third term is 2, fourth term is 3. In this way we have assumed in this program. So, this 0th term, see this, if any user gives the n value to be 0 and the x value will automatically be 0, in that case the output will be 0. And in the case of input to be 1, the x value will take up the value of 1 and the result will also be 1. So, in that case, we see that these are the boundary conditions or the base criteria in which we are going to print the first two numbers. As you all know, in the previous videos, I have also explained that in the Fibonacci series, the first two terms are taken to be the boundary values for which the recursive definition or the recurrence relation doesn't hold. That should be given some values, some values should be attributed beforehand to those base values. So, this 0th term has a value of 0, first term has a value of 1. Once you get these two values, we get two previous values to be added and to get the next term, that is this 1. And then these 1 and 1 get added together to give this 2 and so on and so forth. And now if we see that the user has supplied 0 or 1 as the input, we will definitely print whatever is being given by the user as an input. So, this n will be the output. So, n comes in the way of x in this function body. So, if x contains 0, it will give the output to be 0. If x contains 1, it will give the output to be 1. And in this manner, we have dealt with the boundary values or the base values. So, we have written in this manner, if x equals 0 or logical or x equals 1, return x. That is, we are going to return whatever is in the value of x. So, if x is 0, it will return 0. If x is 1, it will return 1, so as to deal with these two terms. And now the remaining portion of the series will be dealt with by this logic, that is this else portion, this portion. So, this portion deals with the remaining terms. So, now this portion is written as return rec fibo x minus 1 plus rec fibo x minus 2. That is, rec fibo is called in two places by means of the argument as x minus 1, that is whatever is the value of x, that should be subtracted by 1, by 1 should be subtracted from that x value, and actual argument will be x minus 1. And another rec fibo call is there where 2 will be subtracted from the value of x, and the function will be called yet another again from this portion. So, the function calls itself from this place, and the return values of both of these functions will be added up to give the final return value to be assigned to that f variable, which is to be printed as the result of the program or the output of the program. So, now we are going to put some sample values in order to show you the logic. So, let me just rub off a little bit of portion from there to get some space to do the dry run. So, excuse me for that, I am just rubbing off a little bit of portion over here. So, if the user gives a term number 2, n is equal to 2. So, n is equal to 2 is nothing but the user wants to get which term? That is, user wants to get 0, 1, 2. Suppose n is given to be 3. This is the second term, this 1, this 2 is the third term. So, user wants to get this third term to be printed, that is our output should be 2. So, let me see whether this program gives an output of 2, so that we can infer that the program is written correctly. So, this n is 3, definitely rec fibo calls by n value, that is 3, x will be also 3. So, 3 comes over here, x less than 0, it is not that case. We come to this portion, x is equals to 0, x equals 0 or 1. No, that is not the case. We are getting this 3 as x. So, we are going to this else portion and see this return contains this portion. The function is called like this, rec fibo x minus 1 means 3 minus 1 means 2 plus rec fibo x minus 2 means 1, 3 minus 2 means 1. So function is being called by this function call. This is another function call, excuse me, and these two return values from these two functions will be added up to be returned finally. So this function again calls the function by the argument 2. So x becomes 2 over here, rather yes, x becomes rather x or n or whatever you assume, it becomes 2 over here. So suppose this x also becomes, the formal argument also becomes 2, and in that case the function executes in this manner. See this, we are not going to this portion, we are not going to this portion, we are coming again to this else portion, because our case was our x value is not 0 or our x value was not negative or 0 or 1, our x value was 2. So we are coming to this else portion once again, and again we are going to return rec fibo 2 minus 1. 2 minus 1 means 1 plus rec fibo 2 minus 2 means 0. So this rec fibo 1 and rec fibo 0 are there. These two return values should be again added up to be returned by this return statement. So there is a return statement over here also. Rec fibo 1 calls the function by a value which is a boundary value. That is, 1 is considered to be a boundary value by this logic. So our program gets stuck over here. It will not stick over here. It will come over here. It will get stuck in this condition. So if x equals 1, return x. So this portion, this else if with this condition is executed, and it will return the x value. Whatever is the x value will be returned as the return value. So this rec fibo will be returning nothing but return x, that is x is 1. So it will return nothing but return 1. And this portion rec fibo 0 will also be called, and this rec fibo 0 will also be executed by this portion, and it will return 0. So these boundary conditions are being now returned, the boundary values are being returned. So this 0 and this 1 will be now will be returned now. So this one was returned in this statement, and this one will be returned from this portion. So rec fibo, this will return, rec fibo 0 will return how much? 0. So this return 1 and return 0, these are pure values, these are boundary values. So this will be added up together to give you this return value. So this return will return how much? This added value of this 1 and 0. So that will return definitely 1. So it will return 1. So this portion returns 1. And let me see this portion. Let me write this portion over here. Rec fibo how much? 1. So rec fibo 1 means we are again going to this boundary case or the base case. So this base case will be again returned as return 1. So it is again a pure value, return 1. So this will be returned as 1. So this portion will return how much? 1. This portion will return, this rec fibo 1 will return 1. So together this will now be written in this fashion. This will be now considered in this fashion. This return, I am writing this return over here, and this return value is nothing but return 1. So we have returned 1 from here, and this portion returns directly 1. So this one is this one. So this one will be, now this plus sign will be written here, plus, and this rec fibo 1 is nothing but this one, which is returned from this rec fibo 1 function call. So this is 1. So now this is the case it reduces to. It is the situation to which this statement reduces to. So return 1 plus 1 will give you definitely return 2. So the return 2 will be now going to this 2 will be this 2 will be going to this f, and this is not negative, f value is not negative, so it is a valid input case. As we have seen, number 3 is nothing but number 3 is the term. The third term is a valid input, so we are not going to this invalid input line, we are going to this else portion and print %df. So %df means f value is now 2 and 2 will be printed as the third term. So our expected result was, the third term was like this: 0, 1, 2, 2, 0, 1, 1, 2, 3, etc. This was the Fibonacci series. This is the 0th term, this is the first term, this is the second term, this is the third term. We wanted to get the third term to be printed, and 2 was the expected result, and whatever we have found as the output of the program is also 2, because we have returned 2 and that 2 will be assigned to f to be printed later on by this expression statement printf %df, that is we have printed 2. So our output is 2 and the expected value was 2. So the program is written in a perfect manner. The program is now ready to be run on the computer system, and if you have any doubts or queries pertaining to this program, you can well post your doubts and queries into the comment section so that I can address those doubts and queries. Thanks for watching my video.